Hello and welcome to Pre-Algebra Practice Set number 46. In this video, we're going to look at some additional practice problems for our lesson on finding the mean, median, and mode for a group of numbers. All right, so we want to find the mean, median, and mode for each. And we're going to begin today with -3, 15, 7, 21, 7, 2, and 21. So let's start out with finding the mean. And a lot of you will know this as finding the average. To find the mean or to find the average, basically what you want to do is sum the numbers. So in this case, I would just take all of the positive numbers, because I have one negative over here, and add them together. So let's do 21, and we have another 21, and then we have 15, and then we have 7, and then another 7, and then 2. So let's find this sum real quick. So 1 plus 1 is 2, plus 5 is 7, plus 7 again is 14, plus another 7 is 21, plus 2 is 23. Put a 3 down, carry the 2. 2 plus 2 is 4, plus 2 is 6, plus 1 is 7. So that's going to give me 73. So I have 73, and I want to add -3 to that. So this is very easy to do. So 73 plus -3 is the same thing as 73 minus 3. It's 70. Now we have our sum for this group of numbers. So let me just write that the sum is 70. So once I have the sum, all I need to do is divide by the number of numbers, and that will give me the average, or again, the mean. So 1, 2, 3, 4, 5, 6, 7. There are 7 numbers. So we would take the sum, which is 70, and divide it by 7, the number of numbers, and that would give us 10. So 10 is going to be our average, or again, our mean. So let's write that. The mean is 10. Now the next one we want to look at is the median. Now the median is found by arranging the numbers from smallest to largest. So the smallest number we have is -3. And then the next smallest is 2, followed by 7, and we have 2 of those. Then we have 15, and then we have 2 21s. Now once you've arranged your numbers in the group from smallest to largest, the median is the middle number. Now when your group of numbers is an odd number, like in this case we have 1, 2, 3, 4, 5, 6, 7 numbers. 7 is an odd number. So in this scenario, it's a bit easier because you have a middle number, right? This number right here is in the middle. So it's the median. And we know it's in the middle because there's the same number of numbers to the left of it as there are to the right of it. I have 1, 2, 3 numbers, and then 1, 2, 3 numbers. So the middle number is that 7, and that is the median. So let's write that this is the median. And then if you have an even number of numbers, it's a little bit more complicated. Basically, you're just going to average the 2 numbers in the middle. Okay, the last thing we want to do is find the mode. Now, the mode is the number that occurs most frequently in your group. So what are we looking at? We have -3, 15, 7, and then 21, 7 again, 2, and 21. So the numbers that occur most often are 7 and 21. Now, you can see that each occurs twice, and every other number only occurs once. You can have more than one mode. So in this case, we have 2 modes. So I'm going to put that our modes would be 7 and 21. All right, let's take a look at another one. We have 153, 18, 75, -1, 18, and 32. So we're going to start out by finding the mean again. So what is the mean? Again, just sum the numbers. So I have a negative involved. Sum everything that's not negative. So what is 153, 18, 75, 18, and 32? Let's add all that up. So 3 plus 8 is 11, plus 5 is 16, plus 8 is 24, plus 2 is 26. So put a 6 down, carry the 2. 2 plus 5 is 7, plus 1 is 8, plus 7 is 15, plus 1 is 16, plus 3 is 19. 9 down, carry the 1. 1 plus 1 is 2. So you have 296 as your sum. You're going to add that to -1. You're going to add that to -1 and get 295. And then just divide by the number of numbers you have. So you have 1, 2, 3, 4, 5, 6 numbers. So what is 295 divided by 6? 295 divided by 6. 6 does not go into 2. It'll go into 29 4 times. 4 times 6 is 24. Subtract here and you'll get 5. Bring down this 5. 6 goes into 55 9 times. 9 times 6 is 54. Subtracting, you get 1. Let's continue our division by putting a decimal point and bringing it up into the answer. And we'll put a 0 here and bring that down. 6 is going to go into 10 only once. 1 times 6 is 6. Subtracting, you get 4. Put a 0, bring it down. You'd have 40. 6 goes into 40 6 times. 6 times 6 is 36. Subtracting, you get 4. So at this point you can stop because you just had a 4 there, and it became 40 when you brought down a 0. Now if I bring down another 0, I'm just going to have 40 again. So this is a repeating decimal, right? This 6 is going to repeat forever and ever and ever. So we can say it's 49.16 with a horizontal bar over the 6 to say that will repeat forever. So this is 49.16 with a horizontal bar over the 6. So that's our mean, 49.16, again with a horizontal bar over the 6. All right, what about the median? What about the median? Again, arrange the numbers from smallest to largest. So -1 is the smallest. Then next we would look at 18, and there's 2 of those. Then we'd have 32, then 75, then 153. So now I'm looking for the middle number, and that's my median. The problem is here I have an even number of numbers. I have 1, 2, 3, 4, 5, 6 numbers. There is no exact middle number here because we have an even number. If I choose 18 here, that's kind of close to the middle. Well, I have 2 numbers to the left, but 3 numbers to the right, so that can't be the middle. Or if I choose 32, that also looks like it's close to the middle, but I have the same problem. I have 3 numbers to the left and 2 numbers to the right. So what we're going to do is we're going to take these 2 middle numbers and we're going to find the average or find the mean. So what is the average of 18 and 32? Well, we would find the sum first. What is 18 plus 32? 18 plus 32. 8 plus 2 is 10. 0 down, carry the 1. 1 plus 1 is 2, plus 3 is 5. So that's 50. Now I just divide by the number of numbers. So the number of numbers I'm working with here, remember I'm just working with these 2 numbers in the middle, is 2. So 50 divided by 2 is 25, so the median is 25. Okay, so again, if you're looking for the median and you have an even number of numbers, it's a little bit more tedious, right? You got to take the average of the 2 middle numbers. So we sum the 2 middle numbers, 18 and 32, we got 50. Then we divide it by the number of numbers, which is 2, right? We're working with 2 numbers there. And 50 divided by 2 is 25, so that's our median. All right, so what's the mode? That's the next one we're looking at. What's the mode? So that's the number that occurs most often. So if I look in this, I see that I have 18. I have 18 that occurs once and then twice, and everything else only occurs once. So your mode is going to be 18. Hello and welcome to Pre-Algebra Test Section 1 on finding the mean, median, and mode. All right, so we want to find the mean. And remember, this is also known as finding the average. So what we do, we take our numbers in the group. So we have 34, -7, 21, and 8. And we find the sum, right? So we just add them to begin. So since we have a negative value involved, let's add the positive numbers first. So 34, 21, and 8. 4 plus 1 is 5. 5 plus 8 is 13. Put a 3 down, carry the 1. 1 plus 3 is 4, plus 2 is 6. So that result is 63. So now what I need to do is take 63 and add it to -7. So what is 63 plus -7? Well, I know that the absolute value of 63 is larger than the absolute value of -7. So it will be positive, and then I would just do 63 minus 7. So 63 minus 7. Borrow from the 6, this will be 5. This will be 13. 13 minus 7 is 6. Bring down the 5, I'd get 56. So the sum for the group of numbers here would be 56. The sum is 56. Now, the next thing we want to do is just count the number of numbers in the group. So we have 1, 2, 3, 4. And then we would divide the sum by the number of numbers. So what is 56 divided by 4? 56 divided by 4. That's going to be 14. So this equals 14. And this is your mean. This is your mean, or again, your average. All right, let's take a look at another one. we have 5, 14, 25, negative 11, negative 20, and 47. So because I have some negatives involved, I'm going to add the positive numbers first. So 5, 14, 25, and 47. So 47, 25, 14, and then 5. 7 plus 5 is 12, plus 4 is 16, plus 5 is 21. Put a 1 down, carry the 2. 2 plus 4 is 6, plus 2 is 8, plus 1 is 9. So that's 91. So then 91 plus, I have a negative 11 and a negative 20. Negative plus negative is negative, and then 11 plus 20 is 31. So 91 plus negative 31. Now I can almost do this in my head. Now if I have a positive 91 and I'm adding a negative 31, it's the same thing as if I had 91 minus 31. So that's just 60, right? Kind of you can mentally do that as 1 minus 1 is 0, 9 minus 3 is 6, right? Very, very easy to do. Now, I have my sum, and let me just write that that's the sum. The sum is 60. Now I just need to divide 60 by the number of numbers in the group. So 1, 2, 3, 4, 5, 6. So what is 60 divided by 6? That's another easy one to do in your head. That's going to be 10. And so 10 is going to be our mean, or again, you can call that the average. Hello and welcome to Pre-Algebra Test Section 2 on finding the mean, median, and mode for a group of numbers. All right, so again, we want to just find the mean here. And another word to say find the mean is find the average, right? You might be more familiar with that. So to find the average or to find the mean for a group of numbers, you're first going to sum the numbers. So we have 31, negative 72, 100, 512, and negative 10. So to find the sum here, we have some negatives involved. So we want to add our positive values first. So that's 512, 100, and then 31. So 2 plus 0 plus 1 is 3. 1 plus 0 plus 3 is 4. 5 plus 1 is 6. So the positive values here add up to 643. Your negative values here, negative 72 and negative 10, would give you negative 82. So what is 643? What is 643 plus negative 82? Well, of course, the sign's going to be positive, right? 643 has a much larger absolute value. And you're going to subtract the larger absolute value minus the smaller. So essentially, you just have the problem 643 minus 82. So I'm going to start out by doing 3 minus 2. 3 minus 2 is 1. And then I need to borrow here. This will become 5. This will become 14. 14 minus 8 is 6. Bring down the 5. So 561 is the sum, right? That's the sum for this group of numbers. So I'm just going to write here that the sum is 561. All right, now the next step is to divide by the number of numbers in the group. So we have 1, 2, 3, 4, 5 numbers in the group. So I would say, what is 561 divided by 5? And of course, I'm going to do that using a long division. So let's scroll down and get a little room. 561 divided by 5 here. 5 goes into 5 once. 1 times 5 is 5. Subtracting, you get 0. Bring down the 6. 5 is going to go into 6 once. 1 times 5 is 5. Subtracting, get 1. Bring down the 1. 5 goes into 11 twice. 2 times 5 is 10. Subtracting, get 1. To continue, I can put a decimal point and bring that up into the answer. Put a 0 here and bring that down. 5 goes into 10 exactly twice. 2 times 5 is 10. Subtracting, get 0. All right, so we have 112.2 as our answer. So let's go back up to the top, and we'll write that this is 112.2, and this is our mean, right? This is our mean or average. Sum the numbers in the group, then once you have that result, go ahead and divide it by the number of numbers in the group, and that gives you your mean or, again, your average. All right, let's take a look at one more problem. We have 71, 80, 83, 90, 51, and negative 300. So again, if you have a negative involved, just kind of leave that off to the side. We're going to find the sum for 71, 80, 83, 90, and 51. 1 plus 0 is 1, plus 3 is 4, plus 0 is still 4, plus 1 is 5. 7 plus 8 is 15, plus 8 again is 23, plus 9 is 32, plus 5 is 37. So you're going to get 375 there. And now I'm going to add that to negative 300. So that's pretty easy to do even in your head. So if I had 375 plus negative 300, basically I just have the problem 375 minus 300. That's just going to give me 75, right? Very, very simple to do that in your head. Now, once I have 75, I'm just going to divide that by the number of numbers, right? Because that's the sum. So we'll write out real quick that the sum is 75. And we have 1, 2, 3, 4, 5, 6 numbers. So what is 75 divided by 6? 75 divided by 6 is 12.5. And again, this is your mean, or you can say this is your average, 12.5. Hello and welcome to Pre-Algebra Test Section 3 on finding the mean, median, and mode for a group of numbers. All right, so we want to find the median here. And we're going to start out with this group of numbers 88, 20, negative 4, 29, 17, and 103. So to find the median, what we want to do is arrange the numbers from smallest to largest. So the smallest number here is negative 4. So negative 4. And then kind of the next smallest would be 17. And then followed by that is 20, then 29, then 88, then 103. Now, in the scenario where you have an odd number of numbers, this is a very, very easy process. With an odd number of numbers, you just choose the number that's in the middle once you've arranged the numbers from smallest to largest. In this case, we don't have that. We have 1, 2, 3, 4, 5, 6 numbers, so there really is no middle. So what we do in this scenario where we have an even number of numbers is we just take the average of the two numbers that are in the middle. So if I take the average of these two numbers, I would have two numbers that come before and two numbers that come after. Right? I'm just considering this the middle now. So what I want to do is find the average of 20 and 29. And to do that, I sum the numbers. 20 plus 29 is 49. And then I divide by the number of numbers, which in this case we're working with two numbers. So 49 divided by 2. So what is 49 divided by 2? 2 goes into 4 twice. 2 times 2 is 4. Subtracting, get 0, bring down the 9. 2 goes into 9 4 times. 4 times 2 is 8. Subtract here and get 1. I'll put a decimal point here and bring it up into the answer. Put a 0 here and bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtracting, get 0. So 24.5. 24.5. And that's going to be our answer, right? That's going to be our median. So I'll just say that the median is 24.5. And again, when you have this scenario where you have an even number of numbers, it's just the average of the two middle numbers. All right, let's take a look at another one. We have 14, 18, 150, 121, negative 11, negative 20, and 54. So again, let's arrange these numbers from smallest to largest. So negative 20 is the smallest. Negative 11 is the next smallest. Then let's see, we'd have 14, 18, 54, 121, and then 150. And I have 1, 2, 3, 4, 5, 6, 7 numbers. So we have an odd number of numbers. So this is very, very simple. The median is just the middle number, and that's 18. Right? You can see you have 1, 2, 3 numbers that come before it, and 1, 2, 3 numbers that come after it. So it's perfectly in the middle. So 18 is our median. Hello and welcome to Pre-Algebra Test Section 4 on finding the mean, median, and mode for a group of numbers. All right, so we want to find the median. And so for our group of numbers, we have 22, 23, 28, 29, 71, and 15. And to find the median, what we want to do is arrange the numbers from smallest to largest. So in this particular case, all I need to do is take this 15 and put it at the front. So I would have 15, 22, 23, 28, 29, and then 71. Once I've done that, there's kind of two different scenarios. If you have an odd number of numbers, basically your median is just the middle number. If you have an even number of numbers, it's the average of the two middle numbers. So what I mean by that, in this case, we have an even number of numbers. We have 1, 2, 3, 4, 5, 6 numbers. So there's not really a middle number. If I look at 23, there's two numbers before it, but three numbers after it. If I look at 28, there's three numbers before it, but two numbers after it. So nothing's really directly in the middle. So what we do is we average these two middle numbers, right? If you think about these two combined together, right? If we think about those as the two middle numbers, there's two numbers that come before that and two numbers that come after, right? So that's what we're going to consider here. And basically, we just want to take the average of these two numbers. So to take the average, we would sum 23 and 28. So 23 plus 28. 3 plus 8 is 11. 1 down, carry the 1. 1 plus 2 is 3, plus 2 is 5. So 51. And then I would divide by the number of numbers, which in this case, we're working with two numbers, so we're dividing by 2. So what is 51 divided by 2? 2 goes into 5 twice. 2 times 2 is 4. Subtract and get 1. Bring down the 1. 2 goes into 11 5 times. 5 times 2 is 10. Subtract and get 1. Now I'm going to continue my division. Go ahead and put a decimal point here and bring it up. Put a 0 here and bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. So 25.5. 25.5. So that's going to be our median. And again, when you have an even number of numbers, it's just the average of the two middle numbers. All right, let's take a look at another one. We have -2, -7, 14, and -9. So again, I want to arrange the numbers from smallest to largest. The smallest number here is -9. Right? The smallest number, when you have negatives involved, is always the biggest negative. -9 is a bigger negative than -7 or -2, so it's the smallest number. Then the next biggest negative is -7, so that's the next smallest. Then -2, and then of course positive 14 is the largest. Now again, we have the scenario where we have an even number of numbers. I have 1, 2, 3, 4 numbers. So I'm just going to take the middle two numbers and average them. What is the average of -7 and -2? Well, -7 plus -2, negative plus negative is negative, and then 7 plus 2 is 9. So you'd have -7 plus -2 is -9. And then we would divide -9 by the number of numbers, which is 2. So -9 divided by 2 is what? Well, we know it's negative. We know it's negative. And then let's just do 9 divided by 2. 2 goes into 9 4 times. 4 times 2 is 8. Subtract and get 1. Put a decimal point here. Bring it up into the answer. Put a 0 and bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. So 4.5. So this is -4.5, and that's going to be my median, right? Because that's the average of the two middle numbers. So the median for -2, -7, 14, and -9 is going to be -4.5. Hello and welcome to Pre-Algebra Test Section 5 on finding the mean, median, and mode. All right, so we want to find the mode. And remember, to find the mode is very, very, very easy. You're just looking for the number that occurs most often in your group of numbers. So we have 2, -4, 7, 3, 2, 5, 7, 2, 18. So you just kind of eyeball it and see, okay, well, I know that 2 is here, here, and here. So I have 3 occurrences. And then with a different highlighter, I can see that 7 occurs here and here. Everything else only occurs once. Now, 2 occurs 3 times, 7 occurs twice. So the number that occurs most often is 2. So 2 is the mode. And it's just that simple. All right, for the next problem, we have 24, 17, 21, -7, 17, 12, 24, and 13. So let's just take a look at what occurs more than once. So we have 24 that occurs here and here. And we have 17 that occurs here and here. And everything else just occurs once. So 24 occurs twice, and so does 17. So in this case, we have 2 modes. So we would say there are 2 modes. 17 and 24, right? They each occur twice, whereas every other number only occurs once. Hello and welcome to Pre-Algebra Practice Set number 47. In this video, we're going to look at some additional practice problems for our lesson on converting between US units of measurement. So let's start out by just taking a look at some of the common relationships you're going to see between units. So for length, I have that 12 inches equals 1 foot, 3 feet equals 1 yard, 5,280 feet equals 1 mile. For weight, I have that 16 ounces equals 1 pound, 2,000 pounds equals 1 ton. For volume, I have that 2 cups equals 1 pint, 2 pints equals 1 quart, and 4 quarts equals 1 gallon. And then for time, I have that 60 seconds equals 1 minute, 60 minutes equals 1 hour, 24 hours equals 1 day, and 7 days equals 1 week. Okay, so we just want to perform each conversion. And we're going to start out with an easy one. We have 25 feet, 2 yards. So the first thing we want to do is we want to identify the relationship between the units that we're going to be working with. We have feet and we have yards. So earlier I showed you that 3 feet is equal to 1 yard. Okay, 3 feet is equal to 1 yard. So I'm going to write that here real quick. 3 feet is equal to 1 yard. Now the next thing we're going to do is we're going to set up a unit fraction. Now the unit fraction shows the relationship between the two units, and it has a value of 1, right? Just like if I had 17 over 17, right? That equals 1. Even though it's a complicated form of 1, you still follow the rule that if you multiply something by 1, it's going to remain unchanged, right? It might look different, but it remains unchanged. All right, so to set up the unit fraction, we always want to put the units that we want to end up with in our numerator. In this case, we're going from feet to yards. So when I write the relationship here, I want to put 1 yard in the numerator, and I want to put 3 feet in the denominator. And I'm just going to multiply this guy right here by my starting value, which was 25 feet. So we'll have 25 feet times 1 yard over 3 feet. Okay, so the units here that we don't want anymore are going to cancel themselves out. So this feet here will cancel with this feet here. And what I'm going to end up with is basically 25 times 1 over 3. Now, what I'm left with here in terms of units will be yards. And I know it says yard right there, but you can go ahead and just say yards. Yards. We just need to do the calculation of 25 times 1/3, which is basically 25 divided by 3. So 25 divided by 3. 3 does not go into 2. It will go into 25 8 times. 8 times 3 is 24. If we subtract it, we get 1. Let's put a decimal point here so we can continue our division. We'll put a 0 here and bring it down. 3 goes into 10 3 times. 3 times 3 is 9. If I subtract, I get 1. So you see that you have an infinitely repeating digit there, right? You have a repeating decimal. So you would have 8.3333333 where that 3 continues forever. And so let's go back up to the top. And we have two choices basically. So as a fraction, we could say we have 25 over 3. We have that number of yards. Or using a decimal, we can say 8.3 with a horizontal bar over the 3 to say that that 3 continues forever, that many yards. Either way, both answers would be acceptable. Okay, what about 3.5 pounds to ounces? So what's the relationship between pounds and ounces? So I have here under weight, 16 ounces equals 1 pound. So again, 16 ounces is equal to 1 pound. So once we've identified the relationship between the two units we're working with, again, we're going to set up a unit fraction. Now we always want to put the units we want to end up with in our numerator. So we're going from pounds to ounces. So we're going to put ounces in our numerator. So we'll have 16 ounces over 1 pound. Okay, we're multiplying this by what we started with, which is 3.5 pounds. 3.5 pounds. And let's see what we get. We know that the units that we don't want will cancel. So pounds will cancel with pounds. I'm just going to be left with ounces for the units. So let's go ahead and write that down here, ounces. And basically all I have is 3.5 times 16. So 3.5 times 16. And again, you can just ignore that decimal point for now. 6 times 5 is 30. Put a 0 down, carry the 3. 6 times 3 is 18. Plus 3 is going to be 21. I'll go ahead and erase this. Now we have 1 times 35, and that's 35. Bring down the 0. 1 plus 5 is 6. 2 plus 3 is 5. So I've got 560, but notice how I have a decimal point there. So I have 1 decimal place between these two factors. So that means this would go 1 place to the left, and I just have the number 56. So 3.5 pounds would be equal to 56 ounces. All right, let's take a look at another one. We have 42 minutes to seconds. So what's the relationship between minutes and seconds? There are 60 seconds in 1 minute. So 60 seconds is equal to 1 minute. So 60 seconds is equal to, again, 1 minute. All right, so we want to end up with seconds. So when I set up the unit fraction, I'm going to put 60 seconds in the numerator, because that's what I want to end up with in terms of seconds. I'm going to put 1 minute in the denominator. I'm just going to multiply it by the starting value, which is 42 minutes. And our units that we no longer want are going to cancel, minutes with minute. And I just basically multiply 42 times 60. Now, the quick way to do that, because 60 has a trailing 0, is to say, what is 42 times 6? What is 42 times 6? 6 times 2 is 12. 2 down, carry the 1. 6 times 4 is 24, plus 1 is 25. So I've got 252. And then I would just attach a trailing 0 to that. So this would be 252. Put a 0 behind it, so it's 2,520, and then seconds. Okay, so 42 minutes is 2,520 seconds. All right, let's look at one that's a little bit more tedious. And in this scenario, we're going to do multiple conversions in one shot. So we have 3 days to seconds. So we don't know the relationship between days and seconds. And you can figure it out, but in most cases, you're going to know the relationship between seconds and minutes, minutes and hours, hours and days. So what you'll do is, let's start out by saying, we know there's 60 seconds in 1 minute. We know there's 60 minutes in 1 hour. And we know there's 24 hours in 1 day. So I'm starting with 3 days. 3 days. And I want to go to seconds. How many seconds are in 3 days? Well, the first thing I would do to get to seconds starting from days, I would convert it to hours. So my unit fraction here will have hours in the numerator, so 24 hours. And it'll have 1 day in the denominator. This will put our relationship in terms of hours. Now, the next thing I'm going to do is I'm going to get it in terms of minutes. So this relationship between hours and minutes, 60 minutes equals 1 hour. The unit fraction here, I'll have 60 minutes in the numerator. I'll have 1 hour in the denominator. So this puts it in terms of minutes. Now the last thing I want to do is put it in terms of seconds. So I'm going from minutes to seconds. So 1 minute is 60 seconds. So I'm putting 60 seconds in the numerator, and I'm putting 1 minute in my denominator. Okay, so this will finally put it in terms of seconds. And you can see you're just doing multiple conversions in one shot. And nothing more complicated about it. Sometimes the arithmetic is kind of challenging, but if you're allowed to use a calculator, really once you've set it up, you've done all the work. So you can see that everything you don't want is going to cancel. Days will cancel with day, hours will cancel with hour, minutes will cancel with minute, and you're just left with seconds, which is what you want. So this will be something, and then you'll have seconds. All right, so let's do some multiplication here. Every denominator is 1, so you can just look at 3 times 24 times 60 times 60. So let's do 3 times 24 first. 24 times 3. 3 times 4 is 12. 2 down, carry the 1. 3 times 2 is 6, plus 1 is 7. So that's 72. And then I need to multiply by 60, and then by 60 again. I can save myself some time because if I have 72 times 60 times 60, there's 2 trailing zeros here, right? 1 there and 1 there. So what I can do is 72 times 6 times 6, and whatever I get, just attach 2 trailing zeros to the end of that. 6 times 6 is 36. So basically I just need to do 72 times 36, and then whatever I get, just attach 2 trailing zeros. So let's do that real fast. So 6 times 2 is 12. 2 down, carry the 1. 6 times 7 is 42, plus 1 is 43. 3 times 2 is 6. And then 3 times 7 is 21. Let's add here. Bring down the 2. 3 plus 6 is 9. 4 plus 1 is 5. Bring down the 2. So 2,592. And then attach 2 trailing zeros. So 1, 2. You get 259,200. So we'll come back up to the top and say this is 259,200 seconds, right? Again, 3 days was converted to hours, then minutes, then finally seconds. And we got an answer of 259,200 seconds. All right, let's take a look at one final problem. And again, it's going to be one where we do multiple conversions in one shot. So we want to go from 4 tons to ounces. So if you look at the relationships I have here for weight, I have 16 ounces equals 1 pound and 2,000 pounds equals 1 ton. But I don't have anything from tons to ounces, right? I don't have that relationship. You could figure that relationship out if you wanted to, but if you don't know it, you're either going to have to figure out that relationship or do multiple conversions. All right, so 16 ounces is equal to 1 pound. And then 2,000 pounds is equal to 1 ton. Again, we're starting with 4 tons. 4 tons. And the first thing we want to do is go from tons to pounds, right? Because I'm not going from tons to ounces. I don't know that relationship. So from tons to pounds, what I would do is I would multiply by 2,000 pounds over 1 ton. My unit fraction will have a numerator with the units I want to end up with. Next, I'm going to convert to ounces. I'm going to go from pounds, right? This puts it in terms of pounds. So we see 16 ounces equal to 1 pound. So I want to end up with ounces. So ounces goes in the numerator. So 16 ounces over 1 pound. And this will give me what I want, which is in terms of ounces. So you can see everything you don't want cancels. So tons cancels with ton, pounds cancels with pound, and you're left with ounces. Let's put this over here. We'll have ounces. And now we just do some basic arithmetic. We have 4 times 2,000 times 16, right? 4 times 2,000 times 16. And that's pretty easy to do. You could do 16 times 4. 4 times 6 is going to be 24. 4 down, carry the 2. 4 times 1 is 4, plus 2 is 6, so that's 64. Now to multiply by 2,000, I just need to multiply by 2 and attach 3 trailing zeros. So 64 times 2. Well, a lot of you already know it's 128, but 2 times 4 is 8, then 2 times 6 is 12. So that's 128, and again, we're just going to attach 3 trailing zeros. So we're just going to say that this is 128,000, right? I'm putting 3 zeros behind that 8 ounces. So 4 tons was converted to pounds, then ounces, and we ended up with 128,000 ounces. Hello and welcome to Pre-Algebra Test Section 1 on converting between US units of measurement. Okay, so we just want to perform each conversion, and we're going to start out with 32 hours to minutes. So hopefully you watched the lesson. Even if you didn't, you can pick this up from a few practice problems. The first thing you always want to do is identify the relationship between the units. In some cases, if you haven't memorized them, at this point you have to stop and go back and look things up. But for hours to minutes, we deal with time so frequently, most of us will know that 1 hour is equal to 60 minutes. 60 minutes. Once you know the relationship between the units, you're going to set up something called a unit fraction. Now, for the unit fraction, you have to be specific. You want to put the units that you want to end up with in the numerator of the fraction. And the purpose of that, as you'll see, is that so the units that you don't want are going to cancel themselves out. So in this case, we're going from hours to minutes. So we want to end up with something in terms of minutes. So when we look at this relationship here, we want to put 60 minutes in our numerator, because again, we want to end up with minutes. And we want to put 1 hour in the denominator, because we don't want hours anymore. We don't want it in that form. So I'm going to multiply this by our starting value, which is 32 hours. 32 hours. And remember, 60 minutes over 1 hour is just equal to 1, right? They're equal to each other, 1 hour and 60 minutes. So just like when we work with fractions and we multiply by 6 over 6 or 17 over 17, we're multiplying by a complicated form of 1. And so we're not changing the value, we're just changing what it looks like. So let's do our conversion. These units here will cancel. And I know some of you will say, well, this is plural and this is singular. That doesn't matter. You have hours over hour, same units, those cancel out. Next, I have 32 times 60 over 1, which is the same thing as 32 times 60. And that's kind of easy to do. You can do 32 times 6, and put a trailing 0 at the end. 6 times 2 is 12. 2 down, carry the 1. 6 times 3 is 18, plus 1 is 19. So 1,920. Right, I had 192, put a trailing 0 at the end, 1,920. And then don't forget to write your units, which I don't know if I can fit them on that line. Let's bring that down here. 1,920. And then, of course, we have minutes. So 32 hours converted to minutes is 1,920 minutes. All right, let's take a look at another one. We have 330 feet to miles. And this is one that you might not remember, right? What is the relationship between feet and miles? But again, as you look these things up as you're practicing, you're going to memorize them. And then when you get to your test, if your teacher's not nice enough to give you a cheat sheet, you'll know most of these off the top of your head. The relationship between feet and miles, you have 5,280 feet is equal to 1 mile. Now, I want to end up with miles. That's what I wanted in terms of. So when I set up my unit fraction, I want 1 mile on top. Again, that's what I want to end up with. I want to end up with something in terms of miles. And I want 5,280 feet on the bottom because I want to get rid of feet. I don't want that anymore. So then I have 330 feet. Then I'm going to multiply this by. And of course, the units I don't want are going to cancel out. This is going to cancel with this. And I'm just left with this as my unit. So now what I have is 330 times 1 over 5,280. So let's set that up as a division problem. So 330. And we're dividing that by 5,280. Of course, to do this, I have to put a decimal point here, bring that up into the answer, put a 0 here to start my division. 5,280 will not go into 3, will not go into 33, will not go into 330, and also will not go into 3,300. But again, these zeros out here to the left of the decimal point don't matter, so we can kind of skip that over. When we get to this 0 here, we have to put it. It's going to matter because after that 0, I'm going to have some non-zero values, and so that 0 is going to matter. If this ends up getting squished down to the left, it's going to change the value of the number, and I won't have the right answer. So I'm going to put that 5,280 does not go into 3,300. Put a 0 there. 0 times 5,280 is 0. Subtract. I'm going to just bring this whole number down, 3,300. And put a 0 here and bring that down. So how many times will 5,280 go into 33,000? Well, it's not going to be able to go in 7 times. It looks like the answer to that would be 6. Basically, you can kind of approximate that to 5,000 and multiply by 7 and you get 35,000. And you see that's too big already, right? Just with an approximation. So it has to be 6, right? It can't be 7. So what is 5,280 times 6? 6 times 0 is 0. 6 times 8 is 48. Put an 8 down, carry the 4. 6 times 2 is 12, plus 4 is 16. 6 down, carry the 1. 6 times 5 is 30, plus 1 is 31. So 31,680. So 31,680. Let's do our subtraction here. I don't need to borrow here. 0 minus 0 is just 0. I'll borrow here. This will be 2. This will be 10, then 9, then 10. 10 minus 8 is going to give me 2. 9 minus 6 is going to give me 3. 2 minus 1 is 1. So I've got 1,320. Let's put a 0 here and bring this down. So 13,200. So this is only going to go into this twice, right? Twice. 2 times 5,280. 2 times 0 is 0. 2 times 8 is 16. 6 down, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. So 10,560. So 10,560. Let's subtract. 0 minus 0 is 0. And then I need to borrow here. This 2 will become 1. Then this will become 10. 10 minus 6 is 4. Borrow again. This will become 2. And this will become 11. 11 minus 5 is 6. 2 minus 0 is 2. So I get 2,640. Let's go back up to the top. We'll put a 0 here and bring that guy down. So now I have 26,400. And I have the divisor off the screen, but it's 5,280. So how many times will 5,280 go into 26,400? Well, let's think about that down here. We have 5,280 times what? Well, I know that 5 times 5,000 is 25,000. So let's check that 5 out. Let's see if that works out. 5 times 0 is 0. 5 times 8 is 40. 0 down, carry the 4. 5 times 2 is 10, plus 4 is 14. 4 down, carry the 1. 5 times 5 is 25, plus 1 is 26. So that works out perfectly, 26,400. So my answer here is going to be a 5. Again, 5 times 5,280 is going to give me 26,400. Subtract and get 0. So let me erase all this so it's not in my way. And I'll just bring the answer up here. And we'll put equals. And of course I need to put the units behind it. And let me kind of write this on the next line down just so I can fit everything. So again, we started with 330 feet, and we convert that into miles as 0.0625 miles. Hello and welcome to Pre-Algebra Test Section 2 on converting between US units of measurement. All right, so we want to perform each conversion, and we're going to start out with 7 tons to pounds. So the first thing you need to know is the relationship between the units. And for some of the things you're going to know right away because you use it in everyday life, especially measurement in terms of time. But some of you won't know the relationship between tons and pounds, right? It's just something you have to learn through practice. So the relationship is that 2,000 pounds is equal to 1 ton. 1 ton. Now, once you have that relationship, you want to set up something known as a unit fraction. And basically what you want to do is you want to put the units that you want to end up with in the numerator and the units you don't want anymore in the denominator. And what's going to happen is the units you don't want are going to cancel themselves out. So because we're going from tons to pounds, I'm going to put pounds in the numerator. So I'm going to put 2,000 pounds over 1 ton. And just like when we work with fractions, remember if I had 7 over 7, the value was 1, right? 7 is the same as 7. So these two are equal. So when I put them as a fraction, the value is 1. So when I multiply by this complicated form of 1, I'm not changing the value. I'm just changing what it looks like. So I'm going to start out here again with 7 tons and multiply by the unit fraction. Once you've gotten to this point, everything else is just like multiplying with fractions. These units here that you don't want are going to cancel. Tons is going to cancel with ton. And you just basically have 7 times 2,000, right? And then the units after that would be pounds. 7 times 2,000 is easy because of these trailing zeros. You do 7 times 2. That's going to give you 14. And you put 1, 2, 3 trailing zeros behind it. So you'd have 14,000. And then don't forget your units. It's going to be pounds. So 7 tons is going to be equal to 14,000 pounds. All right, let's take a look at another one. We have 360 hours to days. So a lot of us do know the relationship between hours and days because, again, it's something we use all the time. So we know that 24 hours is equal to 1 day. So if I want to end up with days, right, if I want to go from hours to days, then my unit fraction will have days in the numerator, or 1 day in the numerator, and 24 hours in the denominator. So I'm just going to multiply 360 hours by this unit fraction here. And again, the units that we don't want will cancel out. Hours will cancel with hours. And I'm basically just left with 360 times 1 day over 24. Right? Just forget about this unit here for a second. And just think about it as 360 times 1 over 24. That's basically 360 divided by 24. Let's crank out that division. 24 will not go into 3. It will go into 36 once. 1 times 24 is 24. Subtract here and get 12. Bring down the 0. 24 will go into 120 5 times. 5 times 24 is 120. Subtract and get 0. So it's going to be 15. So this is going to be equal to 15. And then don't forget that unit. So 15 days. So again, 360 hours is going to be equal to 15 days. Hello and welcome to Pre-Algebra Test Section 3 on converting between US units of measurement. So we just want to perform each conversion, and we just have one problem to do because it's a little tedious. We have 126,720 inches to miles. So we're going to be doing multiple conversions here in one shot. And let me just kind of scroll up real quick, and we're going to look at the relationship between different units of length. So here I have 2 relationships we're going to use. 12 inches equals 1 foot, and 5,280 feet equals 1 mile. So again, 12 inches is equal to 1 foot. And then again, 5,280 feet is equal to 1 mile. Now, normally what we're going to do, if we just have one step in our conversion, we take our starting amount, which in this case is 126,720, and then the units are inches. We multiply that by a unit fraction where the units we want to end up with are in the numerator. So we're going to do that, but we're going to have to do it twice. So we're going to start out with inches, and instead of going straight to miles, we're going to convert to feet. So I'm going to multiply this by 1 foot over 12 inches. And what this is going to do, again, it's going to put it in terms of feet for me, because inches are going to cancel out, right? Those units will be gone, and I'm just left with this in terms of feet. Now I want to go from feet to miles. So I'm going to do one more multiplication here. And essentially what I'm going to do is I'm going to multiply by a unit fraction where I have miles in the numerator. In this case, it's singular, so just 1 mile. 1 mile over 5,280 feet. And of course, the units here will cancel out. I have foot, and then I have feet. And again, don't get too mixed up between your units being singular or plural. They just cancel out. So now what I'd be left with is miles, right? Miles. Everything else I'm working with is just numbers. So when I go to write my answer, I'm just going to put equals. And let me scroll down here. Again, when I go to write my answer, I'm just going to put that I have miles. And now I can just work with the numbers. So essentially I have 126,720. And that's basically going to be divided by the product of 12 times 5,280. So let's do that on a scratch sheet. Let's first multiply 12 times 5,280. 2 times 0 is 0. 2 times 8 is 16. 6 down, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. Now 1 times anything is itself. But I just need to make sure that, again, I back my answer up because I'd start in the tens place here. So I'd put a 0, an 8, a 2, and then a 5. So let's add, bring down the 0. 6 plus 0 is 6. 5 plus 8 is 13. 3 down, carry the 1. 1 plus 0 is 1. Plus 2 is 3. Then 1 plus 5 is 6. So 63,360. I'm going to just erase everything else. Let's go back up to the top for a second and get that other number. So again, we had 126,720. And we're dividing that by the product of these two, which again we have down here, 63,360. Let me kind of move this up a little bit. And we'll put this like this. Again, so 126,720. Now, these are pretty big numbers to work with, but if you kind of eyeball them, you'll notice that if you just estimate this first number here as 60,000, and you estimate this as 120,000, you can kind of see that this times 2 would give you this. So based on the way that problems are designed, you can kind of eyeball this and guess that the answer would be 2. So let's just multiply this, 63,360 by 2, and see what we get. We're probably going to get this. 2 times 0 is 0. 2 times 6 is 12. 2 down, carry the 1. 2 times 3 is going to be 6, plus 1 is 7. 2 times 3 is 6, and then 2 times 6 is 12. So 126,720 is what you get. And so for the division problem, 126,720 divided by 63,360, we get exactly 2. Right? So we'll go back up, and we know we can just write the answer as 2 miles. Let me kind of move this over a little bit. 2 miles. Okay? So again, 126,720 inches is going to be equal to 2 miles. Hello and welcome to Pre-Algebra Test Section 4 on converting between U.S. units of measurement. All right, so we just want to perform each conversion. And we're just going to take a look at one problem here because this problem here is going to take us a little bit of time. We have to do multiple conversions in one shot. So we want to do 3,240 inches to yards. So we're going to go up to the top real quick, and we're going to look at some common U.S. units of measurement that involve length. So for length, I have 12 inches equals 1 foot, and 3 feet equals 1 yard. So these are the two that we're going to work with here. So again, let's write that down. 12 inches is equal to 1 foot, and then 3 feet is equal to 1 yard. So because I want to go from inches to yards, and I don't know what the relationship is between inches and yards directly, I need to take inches and convert it to feet, and then go from feet to yards. So it's going to be a two-step process. So let's start out with what we have, which is 3,240 inches. And let's convert that into feet. So the way we do that is we set up a unit fraction where feet would be in the numerator. So here I have 12 inches is equal to 1 foot. So my unit fraction would be 1 foot over 12 inches. For the next part, I need to convert into yards because that's what I want to end up with. This puts it in terms of feet. And then I'm going to go from feet to yards. So my next unit fraction will have 1 yard in the numerator over 3 feet in the denominator. This is going to put it in terms of yards. You can see that what you don't want is going to cancel out. Inches will cancel with inches. Foot will cancel with feet. And I'm just left with that unit that I wanted to end up with, which in this case is the singular form where we say yard, but really we're looking at it in terms of yards. So I know in the end, I'm going to have yards down here. So I can go ahead and write that now. And I'm just looking at a basic problem with fractions. 3,240 times 1/12 times 1/3. So 3,240 divided by 36. So 36 will not go into 3 or 32. It will go into 324. Looks like 9 times. What's 9 times 36? 36 times 9. 9 times 6 is 54. 4 down, carry the 5. 9 times 3 is 27. Plus 5 is 32. So you get exactly 324. So 324. Subtract here, and you get 0. Bring down the 0. 36 does not go into 0, so we're going to put 0. 0 times 36 is 0. Subtract and get 0. So we get 90 there. So we're going to put 90 yards for our answer. So 3,240 inches is going to be equal to 90 yards. Hello and welcome to Pre-Algebra Test Section 5 on converting between U.S. units of measurement. All right, so we just want to perform each conversion. And we're only going to look at one problem here because it's going to be one of those problems where we have to do multiple conversions in one shot. So we want to do 22.5 days to seconds. So again, if you don't know the relationship between days and seconds, you're going to have to break it down to a multi-step process. We know that 60 seconds equals 1 minute. We know that 60 minutes equals 1 hour. We know that 24 hours equals 1 day. So to go from days to seconds, essentially what I'm going to do is I'm going to start out with 22.5 days. And I'm going to multiply by a unit fraction where hours is going to be in my numerator. So 24 hours over 1 day. And why did I do that? Well, basically what I'm going to do is I'm going to take days, convert it to hours, then I'm going to take hours, convert it to minutes, and then I'm going to take minutes and convert it to seconds. So basically I'm going through it that way. Now, this puts it in terms of hours. Now, the next thing I want to do, as I mentioned, was put it in terms of minutes. So I would multiply again, and now I'm going to have minutes in my numerator, so 60 minutes over 1 hour. And I won't be able to fit all this on the screen, so I'm just going to scroll over a little bit. The last thing I want to do, since this puts it in terms of minutes, is multiply by, and you'll see all the way up here at the top, I have 60 seconds equals 1 minute. So multiply by 60 seconds over 1 minute. This will put it in terms of seconds, which is what I want. I just want you to see that the units here that you don't want are going to cancel. Days will cancel with day. Hours will cancel with hour. Minutes will cancel with minute. So now all I'm left with for my units is seconds. So I'm going to put equals something and then seconds. So let's think about this multiplication problem. All the denominators are 1. So essentially I just have to think about 22.5 times 24 times 60 times 60. Now I'm going to do 60 times 60 last because each has a trailing 0. So what is 22.5 times 24? So 22.5 times 24. And again, just ignore that decimal point. I'll just erase it for now. 4 times 5 is 20. 0 down, carry the 2. 4 times 2 is 8, plus 2 is 10. 0 down, carry the 1. 4 times 2 is 8, plus 1 is 9. So that's 900. And then we move to the left, so we start here. 2 times 5 is 10. 0 down, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 2 is 4. So we add here, bring down the 0. 0 plus 0 is 0. 9 plus 5 is 14. 4 down, carry the 1. 1 plus 4 is 5. So 5,400. So again, our result was 5,400. But remember, we multiplied, and we had one decimal place between the two factors. So this decimal point would go one place to the left, and essentially I would just have 540. Now we need to multiply this by 60, and then times 60 again. Now we're in luck because we have trailing zeros here. And so what I'm going to do is I'm going to multiply 54 times 6. I'll take that result, multiply it by 6, and then I'll attach 3 trailing zeros to the answer. So 6 times 4 is 24. 4 down, carry the 2. 6 times 5 is 30, plus 2 is 32. So I've got 324. So let's multiply that by 6. 6 times 4 is 24. 4 down, carry the 2. 6 times 2 is 12, plus 2 is 14. 4 down, carry the 1. 6 times 3 is 18, plus 1 is 19. So I've got 1,944. And remember, you've got 3 trailing zeros between these factors. You got one there, there, and there. So I'm going to put 1, 2, 3 trailing zeros there. And I get 1,944,000. So let me kind of scoot this over. We have 1,944,000. And again, this was in terms of seconds. So we have that 22.5 days is equal to 1,944,000 seconds. Hello and welcome to Pre-Algebra Practice Set number 48. In this video, we're going to look at some additional practice problems for our lesson on converting between metric units. All right, so we just want to perform each conversion. And we're going to start out with 32 kilograms to decagrams. So I kind of showed you an easy method to do this in the lesson. Basically, what we're going to do is we're going to use a prefix chart to convert between our metric units. Now, the way this works is you identify the prefix in what you're starting with and what you're converting to. So the prefix for kilograms would be kilo, right? That's the part that comes before grams. And the prefix for decagrams would be deca. Now you find those on the prefix chart. So your prefix chart has kilo here, and it has deca here. And then you basically just match the movement and the direction from the prefix chart and the number where you're converting. So we have 32. Let's write that real quick. And I'm going from kilo to deca. So if I look at my prefix chart, I'm starting at kilo here, and I'm going 2 places to the right to end up at deca. So all I need to do is take 32 and move my decimal point 2 places to the right. So I'm going to put 2 zeros behind the decimal point, and I'm going to go 2 places to the right, and I'm going to end up with 3,200, and then what I'm converting to, decagrams. So decagrams. Let's take a look at another one. So we have 14 liters to milliliters. So again, we're looking at the prefixes to start. So liters is the basic unit. So that's right here. And then milliliters, we have milli, that comes before liters. That's right here. So I'm going to write my number down, which is 14. And I'm going from the basic unit, liters, to milliliters. So that means I'm going to go on the prefix chart 1, 2, 3 places to the right. And I just need to match that movement with my decimal point in this number. So I'm going to put a decimal point here. And I'm going to need to add 3 zeros behind the decimal point. So 1, 2, 3. and then I'll move this decimal point 1, 2, 3 places to the right, and that's going to give me the number 14,000. And then go ahead and write your units that you're converting to, which in this case is milliliters. So 14,000 milliliters. All right, for the next one, we have 1.97 hectometers to decimeters. Now again, we want to identify the prefixes here. I have hecto that comes before meters, and then I have deci that comes before meters here. So we're going from hecto to deci. So here's hecto, here's deci. So to do that movement on the prefix chart, I'm going to go 1, 2, 3 places to the right, and I basically just need to match that with the number. So 1.97, I need to put 1 0 behind that 7, and I'm going to go 1, 2, 3 places to the right. So let me erase this, and I would get the number 1,970. And then, of course, you're going to write your units that you're converting to, which in this case is decimeters. So 1,970 decimeters. Okay, let's take a look at another one. We have 0.38 kilograms to centigrams. So again, identify your prefixes. You have kilo here, and you have centi here. So here's kilo, and here's centi. So I'm going to go 1, 2, 3, 4, 5 places to the right on the prefix chart, and I just need to match that with the number part. So I have 0.38. I'm going to need to put 3 zeros behind the 8. 1, 2, 3. And now I'm just going to move the decimal point 5 places to the right. 1, 2, 3, 4, and finally 5. So let's erase this and put a comma in. So I'll have 38,000, and then write the units you're converting to. Centigrams. All right, let's take a look at one final problem. We have 93.98 decigrams to decagrams. So again, identify the prefixes here. You have deci, that comes before grams, and you have deca, that comes before grams. So here's deci, and here's deca. So on our prefix chart, we're going to go 1, 2 places to the left. So I'm going to take this number, 93.98. So I'm going to go 1, 2 places to the left. So that'll go right there. And I'll end up with 0.9398. And then write the units you're converting to, which in this case is going to be decagrams. So 0.9398 decagrams. Hello and welcome to Pre-Algebra Test Section 1 on converting between metric units. All right, so we want to perform each conversion, and we're going to start out with 12.35 hectograms to decigrams. So remember, when you work with the metric system, it's super easy to do conversions when you have a prefix chart like we have here. So when we start, all we basically need to do is identify our prefixes that are used in the conversion. So we're starting at hectograms, right? So hecto is the prefix, and then we're going to decigrams, so deci is the prefix there. So just identify those on the prefix chart. We have hecto here, and we have deci here. Now, all we need to do is take this number part for what we're converting, so 12.35, and we move our decimal point the same number of places and in the same direction as we move for the prefix chart, right? So we're just matching the movement. So if I'm starting at hectograms and I'm going to decigrams, I just think about, okay, I'm going from hecto to deci. That's 1, 2, 3 places to the right. I just match that with my decimal point. 1, 2, I need to put a 0 in, and then a third place to the right. So let's erase this, and we would have the number 12,350. And then, of course, I'm going to write the units that I want to end up with, which in this case is decigrams. So 12.35 hectograms is the same as 12,350 decigrams. All right, for the next one, I have 38.75 liters to decaliters. So if I look here, I don't have a prefix on liters. It's the basic unit, this right here. And then for decaliters, I have deca that comes in front of liters. That's going to be right here. Now on my prefix chart, to go from the basic unit to deca, I just simply go one place to the left. So I would match that movement with my number, 38.75 38.75. Just look at your decimal point, and again, just match the movement. So it's going to go one place to the left and end up right there. And if I erase this, I'd have 3.875. And of course, write what you're going to end up with in terms of units. That's going to be deca, going to be decaliters. So 38.75 liters is the same as 3.875 decaliters. Hello and welcome to Pre-Algebra Test Section 2 on converting between metric units. All right, so we just want to perform each conversion, and we're going to start out with 19.813 centigrams to milligrams. So essentially converting between metric units is very, very simple if you have a prefix chart available. So I have a prefix chart here. Basically what you want to do is look at the prefixes involved in your conversion. Just go ahead and highlight them and then highlight them on your prefix chart. So we have centi that comes before grams, and we have milli that comes before grams. So we're going from centi, which is here, to milli, which is here. Now take your number that's involved in the conversion, in this case it's 19.813, and just match the movement in terms of the number of places and the direction from your prefix chart with your decimal point in the number. So for example, here I'm going from centigrams to milligrams. So centi is your first prefix, and you're going to milli. So that's one place to the right. All I need to do is look at my number, take the decimal point, and match that. So I'm going to go one place to the right here as well. And my new number would be 198.13. And then just follow it up with the units that you're converting to. So that's going to be milligrams. So 19.813 centigrams is the same as 198.13 milligrams. What about 475.32 decameters to decimeters? Well, again, identify the prefixes involved. You have deca here that comes before meters. You have deci here that comes before meters. And just locate those on the prefix chart. So you have deci here, you have deca here. Now we're going to take this number that's involved in the conversion. In this case, it's 475.32. And we're just going to match the movement as far as the number of places we move and the direction we move from the prefix chart with our decimal point in the number. So I'm going to go from deca to deci. So I'm going to take this and go 1, 2 places to the right, and I'll just match that here. I'm going to go 1, 2 places to the right. Go ahead and erase this, and I'll put a comma in. I'll have 47,532, and then follow that up with the units you're converting to, which in this case is decimeters. So 475.32 decameters is the same thing as 47,532 decimeters. Hello and welcome to Pre-Algebra Test Section 3 on converting between metric units. All right, so we just want to perform each conversion. And we're going to start out with 53.27 kilometers to meters. So converting between metric units is very, very simple, particularly when you're using a prefix chart. So the first thing you want to do when you're using a prefix chart is identify the prefixes involved in your conversion. So in this case, we're going from kilometers to meters. So I have kilo here that comes before meters, and then I'm converting to the basic unit meters. Now locate those on the prefix chart. I have kilo here, and then I have the basic unit, which in this case is meters, right here. Now we just want to match the movement from the prefix chart in terms of how far we're moving, right? The number of spaces we move, and then in the direction that we move with our decimal point in the number part for what we're converting. So 53.27 is the number part, and I'm going from kilometers to meters. So on the prefix chart, I would go from kilo, and I go 1, 2, 3 places to end up at the basic unit, which represents meters in this scenario. And so we would match that movement here with our decimal point and go 1, 2, put a 0 here, 3 places to the right. And so we'd end up with the number 53,270, and then follow that up with the units that you're converting to. In this case, that's going to be meters. So 53.27 kilometers is equal to 53,270 meters. All right, for the next one, we're looking at 13 liters to milliliters. So again, we have the basic unit involved, which is right here. And then we have milli, which comes before liters. So milli is right here. So take our number part, which is 13. And then we're going from the basic unit, and we're going 1, 2, 3 places to the right to get to milli. So I'm going to match that movement here. So I'm going to put a decimal point here. I'm going to put 1, 2, 3 zeros behind it. And then I'm going to go 1, 2, 3 places to the right. And so this is going to end up being 13,000. So 13,000, and then again, just follow that up with the units that you're converting to, which in this case would be milliliters. So 13 liters is the same as 13,000 milliliters. Hello and welcome to Pre-Algebra Test Section 4 on converting between metric units. All right, so we want to perform each conversion. And we're going to begin with 0.4251 kilograms to grams. So the way we do this, we use a prefix chart. So here's the prefix chart here, and we just identify the prefixes involved in our conversion. So for kilograms, kilo comes before grams, and we'll locate that on the prefix chart right here. That's kilo. And then for grams, there's no prefix there because that's the basic unit. So we'll highlight that there. Now all we need to do is take this number part, which in this case is 0.4251, and match the movement that we do on the prefix chart with our decimal point in the number. So for example here, since I'm going from kilograms to grams, I'm going to go 1, 2, 3 places to the right. And so I would match that with this decimal point. I would go 1, 2, 3 places to the right. And so I'd end up with 425.1. And then write the units that you're converting to. In this case, that's grams. So 0.4251 kilograms is the same as 425.1 grams. All right, for the next one, we have 0.875 decaliters to centiliters. So again, we're going to identify the prefixes involved. So we have deca here, and we have centi here. Now, if I look at my prefix chart, here's deca, and here's centi. So I'm just going to match this movement with my decimal point in the number, so 0.875 here. And basically what I want to do, I want to go 1, 2, 3 places to the right to go from deca to centi. So I'm going to match that with my decimal point. I'm going to go 1, 2, 3 places to the right, and I'd end up with the number 875. Now, of course, then I want to write the units that I'm going to convert to. So then centi, and then liters. So 0.875 decaliters is the same as 875 centiliters. Hello and welcome to Pre-Algebra Test Section 5 on converting between metric units. All right, so we want to perform each conversion. And we're going to start out with 0.005318 kilometers to decimeters. Now, for metric conversion, the simplest way to do it is to use a prefix chart. Now, if you start out with a conversion, you look for the prefixes involved. So in this case, we have kilo and we have deci, right? It's what comes before meters. Just locate those on your prefix chart. So we have kilo here and we have deci here. So 0.005318. We're going from kilometers to decimeters. So from kilo, I'm going to start. I'm going to go 1, 2, 3, 4 places to the right. I just need to match that with my decimal point. 1, 2, 3, 4 places to the right. That's going to go right there. And I can erase all of this, and I can erase these zeros to the left of the 5. They no longer add any value to the number. So I'd have 53.18, and then follow that up with the units you're converting to, which in this case would be decimeters. So 0.005318 kilometers is equal to, or is the same as, 53.18 decimeters. All right, for the last one we're going to look at, we have 0.147 decaliters to kiloliters. So again, just look at the prefixes involved. We have deca and we have kilo. So if we look at those on the prefix chart, we have deca here and we have kilo here. Now I'm going from deca to kilo, so that represents a movement to the left. So I'm going to go 1, 2 places to the left, and I just match that with the decimal point in the number part. So 0.147. Let me kind of back that up a little bit. So again, 0.147. I'll need to put 2 zeros to the left of the decimal point, and then I'm going to go 1, 2 places to the left, and I'll erase all of this. So I'll end up with 0.00147, and then again, the units you're converting to. So kiloliters. So 0.147 decaliters is the same as 0.00147 kiloliters.